Good day and welcome to this session of Android. Today we'll look at how you can create a simple app that makes use of the built-in SQLite database system on your mobile device. So we'll be using Android to demonstrate these concepts. Make sure you have the latest version of Android Studio installed, and let's start with the project. So with Android Studio open, create a new project. And once again, there's a ton of choices here for what you can use as the basic template of your app. Just pick empty activity so we don't get all the extra code that the other selections have. Also, don't pick no activity because if you don't have at least one activity, your app will not work unless it's a module for something else. We will be making the app only for phone and tablet, so we won't use the other options here. But if you're curious, you can try them out um, when you're free. So you can do apps for Wear OS or basically Android watches, Android TV, or those TVs that are powered by the Android operating system, automotive, for cars that have Android, and things which are devices that are not TV or watches or cars. But again, for this particular sample, we will be concentrating on phones and tablets. Pick an empty activity and then we'll click on next. The name of the application is what appears on the device again. So we'll just name this as DB sample. We're still using Java for this sample, and the package name gets filled out automatically. And of course, make sure that you have a folder on your computer that's set aside for your Android project. So mine is actually on the desktop. There's a folder called Android Projects, and automatically Android Studio will create a new folder for your new project. Language is Java, and the minimum SDK again is the lowest version of Android that your app will support officially. Right? So I always say officially because uh, people can try to install your app if they have a copy of the APK on versions that are lower than the minimum that we set. But for apps that are officially in Google's Play Store, if someone tries to go to the Play Store and their device does not meet your minimum SDK requirements, they will not see your application on the Play Store. So automatically, Google Play will filter out apps based on the version of Android that the accessing device has. Um, so it tells me that if I pick Android 5.1 Lollipop, I am assured that it will run on 92% of Android devices. Now, there's a checkbox here for use legacy Android support libraries. You won't do that anymore. It's 2021 already. Android X, which is the modernized Android libraries, came out about 3 years ago. So that's enough time for it to mature and be useful for our purposes. The support libraries are still there for older versions before Android X. And so again, Android X is the current support library version of Android, and it's unified now. So it's moving forward. You just depend on one support library. Before Android X, there were versions per new SDK number that came out. So that wasn't sustainable in the long run, and they unified it in X. But in case you're maintaining older Android apps, you still have the option to make use of the older libraries. Again, this is a new app. We don't need those old libraries. We just need Android X. So we won't put this checkbox. In fact, you should not be putting in that checkbox for any new Android project. So we'll click on Finish. And as usual, this is the test of patience as we wait for Android Studio to finish processing the project. Might take some time if your machine has RAM lower than 8 gig. So at this point in time, the minimum, I always say, for a machine that will run Android Studio well should at least be 8 gigabytes of RAM. And your Intel fan, it's at least a Core i5. Or if you're an AMD fan, then it's a Ryzen 5. But the memory is important here. It should be at least 8 gig. Ideally, you should have 16. That's much better. And will give you a better experience when using Android Studio as your IDE. So now Android Studio tells me my new project is ready. Then you look at the bottom of the Android Studio window where it will have the status or whatever it's doing at the moment. And we see the normal things we see when we're creating a new Android project. So to test it out, we'll click on play. So since version 4 of Android Studio, running the emulator is easy enough that I don't need to run it beforehand. Again, assuming that you have at least 8 gigabytes of RAM. If you don't have at least 8 gigabytes of RAM, what you do is go to the AVD manager and then run your emulator from here. Okay, so you'll notice I have Nexus 6 emulator and then one named Dino. Dino occupies 9.9 gig already on my hard drive. So just keep that in mind in case you go crazy with creating different emulators. They do eat up a lot of space on your computer. If I had less than 8 gig of RAM or I was using an older version of Android Studio, I would be running this emulator first. But since I do have 8 gig and this is a Core i7 machine, then at least I can click on play. And since I've ran emulators previously, it already has an image that's ready to run. So I'm confident that I can click on play and my emulator will not take too much time booting up. So as you can see from the screen, we have a working application. So it doesn't do much. There is no functionality whatsoever. So as a reminder, when you create a new project in Android Studio, it's a Hello World application. So that previous Hello World you were seeing on my screen was my previous new project. This is the new one. So I overestimated the speed of the emulator on my computer, but as we can see now, this is the sample. So the name that you give your application will always appear on the title bar, and just like any new project in Android Studio, it says Hello World. And so we'll go back to what we're going to concentrate on today. Again, it's making use of SQLite, which is found on your Android device. It's also found on iOS. SQLite is a fully functional relational database management system, pretty much like SQL Server or MySQL, except it's only 300 kilobytes big. And that's why device manufacturers like to include it in their device. So it's not like SQL Server, Microsoft's database that occupies gigs of space on your hard drive, or MySQL. It's 300 kilobytes. It's a fully working system. The only thing it doesn't have are the graphical elements of much bigger relational database management systems. So it's on phones and it doesn't really need the graphical element because it will be used by apps themselves. So SQLite again, if you want to explore it some more, you can go to their official website, sqlite.org. It's a good option for people who are creating websites and want to have a database in their system. It's pretty much open source, it's pretty much free, and it is small again, 300 kilobytes. So a lot of folks use it as the database of choice for their websites. And again, for devices uh, that use the Android platform or iOS, it is also on all those devices. So now I'm sure that my project is fine and it's running in the emulator. I know my emulator works, so I'll go back to Eclipse. To Android Studio. Eclipse used to be the official Android development environment, but not anymore. Not since 4 years ago, 5 years ago, when Google went to IntelliJ and said, "We like your modern features. We want to use you as the official IDE for Android development," and IntelliJ came up with a version specific to Android development, and that became Android Studio. So normally, if you try to recall what your own experience before in creating Android apps, you'd probably start creating logic here and a bunch of other stuff. Using SQLite in your apps needs some preparation. So unlike in your own previous experience, we'll start off preparing the helper Java classes that the application needs, so that when we get to main activity, we do not need to add a bunch of code here. We will just get the functionality from the helper classes. So we'll start off with the first one. Okay, so you might be used to adding extra activities at this point, but what we're adding are well, they're not simple. We're adding extra Java classes that are not activities. So what you do is right click on the package name and then select Java class. Then it will, so new Java class, and I give it a name. We'll name it VB helper, and it's a class. And then it will ask for an import block. We won't add any stuff here right now, and I'll click on OK. So we now have 3 files that are relevant to this project: the screen, which is in XML, main activity, which is our main module and gets run the first time you start the app, and DB helper, which will encapsulate our database functionality. So now I'll add the stuff that this needs to work through the magic of copy and paste, so you guys don't watch me type in all the code. The code will be available. Just take a look at our common references, and the PowerPoint containing the code will be there along with a written step-by-step process similar to what you see on the video. The proper code will be in the notes section of each relevant slide, and make sure that you copy and paste it correctly so that it's easier. Okay, because there is a lot of code here, so I'll add the imports first. They will turn gray because they aren't being used yet by any other code below them. So next, I'll add the preliminary code. So that's now inside DB helper. And the initial code includes items that are needed by SQLite to work. So since we don't have a graphical element to SQLite, in order to create a new database, you actually issue a create table command. So we'll put that in a string, and then create table would of course contain the description for our columns. There are only two columns in this simple example. One is the primary key column called underscore ID. Then the second one, which will contain actual data, is the code column. We'll also have a string called db helper, which we'll use for tags later on when we're debugging the application. And then the database name is CoachDB, and the table name itself is Coach. So off the bat, you might be thinking, this is a lot of work to have one database with one table inside it that contains two fields, and it is. So every time you tell yourself that you need an internal database to contain local data for my user, uh, this is the initial setup that you need to do. So once you code it, of course, it's a lot of work, but once it runs, then it's fine. Um, but it does entail a lot of work. And that's also why you have to consider why you need a database to store local information. So take note of the other choices. There are shared files and local storage that let you retain information, or I should say shared preferences, especially if you're just remembering a username and password, for example. Uh, that doesn't need a database. You can just use shared preference. Or, for example, a shopping, you're making a shopping app like Lazada or Shop. So that entails a lot of data, but most of that data will not be local on the device. Will be in the cloud somewhere, and your app just pulls it from the cloud. Okay, so again, using the internal SQLite database um, takes a lot of work. So you really have to decide and find out why you want to use it in your application. So going back to the code, I've, I've added the import statements, and I've also added the initial code. So the first three lines of code here define the fields as well as a helper text for debugging. Next three lines define the name of the database and the name of the table inside it, and then the database version. So the version is important because if in case something changes about it and you want to overwrite the existing one, you have to change this version number. Or you have logic in your code that checks if there have been changes in the database. The next line is just a string that defines the table creation syntax in SQL for your database. So you create a table called quotes with two fields, ID of type integer with a primary key, and it auto increments. So every time we add new information, we get that. And we also have a second field called code that contains text and is a required field. So just two fields, one of them automatically increments, and then the other one contains the actual info that we're going to try to save. Then we also have an error here for now. It says private final context. And it says the error is because we haven't initialized the context variable yet, which we'll do in the next piece of code. But you'll now see that because we made use of the context object here, the import on top is not gray anymore. So that tells us that it's being used in code. That's also your guide. If some of the import statements you've added are in gray, it means that in your code you don't actually use it, and you may want to delete the gray import statements, because if you ask Java and then ultimately Android to import something, the application reserves memory space for those imports. So if you see gray stuff, it's a warning that says you're not being efficient about the code that you're doing. So after context, I'll add a few more lines of code, which will have some errors. And again, you can cross-reference this with the copy on the PowerPoint later on. So I'm adding a few things. One, I'm adding a private variable called dbh, and it says helper. So that helper is actually, and we'll code that later on, the helper class is the one that actually defines basic database functionality. We'll also define an SQLite database object called db, and we'll create a constructor for db helper. So what the constructor does is set the context. So context again in Android means it just tells whatever piece of code you're using that it's in this app. So this dot context equals the context, and then we create a new instance of the db helper object. So ultimately, there's an inner class that takes care of the functionality, and we'll add that next. So I'll add the inner class, and I'll add the missing curly brace. So now when I add it, it extends the object called SQLite Open Helper. SQLite Open Helper encapsulates the functionality that we need, which is to create a connection to SQLite and actually manipulate the database object. Right now, it has an error because the required methods for SQLite helper has not been defined yet. So as a refresher, when we have errors like that, we can type it ourselves, or we can make use of the IntelliSense functionality of Android Studio. Click on the drop-down arrow beside the red light bulb. Usually that first suggestion is one that is correct, but to put it in actual context, there are two choices here. We're not creating an abstract class, so definitely it's not the second one. But we should know that the reason why there's an error here is because when we inherit, the extends keyword again, is our clue that helper will inherit from SQLite Open Helper. The parent class, SQLite Open Helper, needs some methods implemented. So we'll do that to correct this error. Right, bug implement methods. It will give us two methods that need to be implemented. I'll click on OK. So those two methods are here now. So that first one is on create, and then the second one is on upgrade. So on create happens when we run the app for the first time on the device, and then it checks, does this app already have a database to work with? Finds out it doesn't, then it runs whatever you wanted to do for on create. Now in case the app already has a database, it was installed previously, then it runs on upgrade if there's a need. So we still have an error here. We'll go there. So not only will the inner class helper require two methods to be implemented, it also requires that we have a constructor that matches the parent or superclass. So we'll also add that. And then it asks for a couple of versions: string factory, cursor factory, version int, open param. So just pick the first one, then click on OK, and that will get rid of the error. So we still have an error here because there is no constructor that takes this in. So we'll fix that. right now. So I'll replace the super line inside, and then I'll also delete the items here, leaving only one argument. Okay, so for the constructor of the inner class helper, we only need to pass one parameter to it, the context parameter. So it just has to know that it's inside this application, or whatever database it needs to interact with is for this application. Now, it will just make a call to super so that it makes use of the actual superclass constructor that contains the context, the database name, and database version. Okay, so that's what we want to do. These two are already declared on top, so we just use their names. And then we'll fill in on create and on upgrade. On create is easy enough. We just want to put in, okay, so we just want to put in the creation of the database. And then on upgrade will be somewhat more involved. So on upgrade, we'll drop the table if it exists. Okay, so I'll just correct some of my code here. The name of my table is quotes if exists, drop table if exists, quotes. Um, and then I'll define the two variables that are read here. So I'll just fix this, and I'll also have to fix this because the ones that are given by IntelliSense are not that descriptive. So this is old version, and then this is new version. To get rid of those errors. So this completes your DB helper class. And then you might be scratching your heads and you're going, what the heck does this do? For all that code that we did, the DB helper class's main thing is to create the SQLite database. So it's just one of many parts that we need to make use of SQLite. And at this point, if you're telling yourself, this is a lot of work, well, it is. Okay. And sometimes you do have apps that will need the internal SQLite database, but that's why I keep telling people you have to really think hard about why you want to make use of SQLite. So we'll continue and add the other parts. Hey, welcome back. And what we'll be doing now is completing DB helper. So aside from just creating a database, we'll add open and close. So the app can establish a connection to the database as well as stop that connection if it's not using it already. We will also be adding insert, update, delete, and select. So the four basic SQL commands will be part of DB helper. And that is why its name is DB helper. So make sure your project is still open and we'll add it now. Oh, before I continue, of course, we have to check if whatever we added here has affected the entire project, and we'll just run it. So since this is version 4 of Android Studio, you don't really need to stop it so that it has to recompile everything. Now, even while it's running in the emulator, you can click the play button. Just notice it has a different icon if the app is still running, and it will partially compile the new parts that need to get compiled. So now that I run it, I open the emulator. Since we only added that helper class, it doesn't really change how it looks like here. So it says succeeded, and you just see hello world still there. We'll change that later on. So now we'll add open and close. Okay, so just so I don't make a mistake, so I'll put comments here. The helper inner class to help with creating and then at the end you can just put and helper class. Give this the proper indentation, and then we can add the rest of the code for DB helper. So again, make sure this is my inner class called helper. It ends here, and all it does is to either create a new database if the app is installed for the first time, or to upgrade it. Now the other stuff, we'll start off with open and close. So open will establish a connection with the database, and close will close it if we don't need it anymore. The next thing we'll add are the 4 basic SQL commands. Before we do that, let's take a look at open. So open will throw an SQL exception, so we can put a try-catch block in main activity in case something goes wrong. Then it makes use of the DB helper object to establish the connection, and what we get is a writable database. So use DB, return it. That DB in turn will be used on the main activity side. And if we're not using it anymore, we close the database. So now on to the basic data manipulation commands. So you have insert, update, delete, and of course to get information we have select. So take note, what we'll do here now is to actually create methods for those 4 items. So we'll start off with insert and delete. So what we'll do for insert is it will, what we're basically saving is just text input from the user. And when we call the insert code function, it will make use of something called content values. So content value makes use of key value pairs. So the key is what you use to get it later on. And then the pair, of course, the value, of course, is the actual data you want saved. That's why it's called a key value pair. And notice that we do not need to use an actual insert statement, an actual SQL insert statement, because the database object already has it as part of its functionality. What it does need to know are the data that we need to insert into the table. So we mentioned the table name. We also mentioned or we also send it the key value pair. And then for delete, it's the same thing. We don't use an SQL statement. We do need to tell it what to delete. and it's just one function. So that's why you make use of these libraries, so you don't need to do those commands from scratch. Now we'll complete this. We'll add update and select. So for select, we'll have two versions. One that returns all of the records from the table, and then another one that just retrieves certain records. So for getting back all the codes, we create a function called all codes. And then it makes use of a cursor object. So in normal database programming, normally you send the results to a cursor object so you can scroll through the records. SQLite has the same thing. It does have a cursor object. And we use the function query, which has arguments similar to a select statement. So it has to know the table, what type of data it's getting. In this case, it's a string array because there are two values there, the ID and the code. Selection null, arguments null. So it's a basic select statement. We don't have any of these other items, and that gets returned by the function. The second function returns a particular code given a certain row ID. So same thing, we use the query function, and this time under the selection argument, we say key ID is equal to the given row ID. So key ID is the column name for our column. Again, you can go back up and check the initial declarations. If the cursor is null, that means nothing was retrieved. So we just move to the first record, and that's for getting a single record. Again, first one is to get all records. Second one is to get a certain record based on the ID. And then last one for update. Update makes use of an update function in the DB object. And it just needs a key value pair. So the primary key plus the update to the quotation, we just call update. And again, the SQL is abstracted. So by adding these items, we now complete DB helper. So to review that, so DB helper started off as, and I'll open my Project Explorer again. We have main activity. Again, in Android applications, by tradition, all activity classes have the name activity in their file name. So that if another Android developer looks at your code, they know immediately that some of the classes there are activities. Now, for non-activity classes, they should follow the normal Java naming convention. So we have DB helper there because there is no activity in its name. Another Android developer will assume that this is not an activity class. So there's a reason to those names too. So we have DB helper. I'll close Project Explorer again. We have the imports up here. If we start pasting that, then what do you call this? It'll be gray until we fill out the code here. So always mind where your curly braces are. What might help you is to add comments at the end and so that when you're inserting stuff, you don't accidentally delete one of those curly braces. So what DB helper will do is, one, it can help create a database because it has an inner class called helper, which just does that, or upgrade it in case it needs to. And other than that, it also helps us connect to that database that it creates, and then do the 4 basic SQL processes: insert records, update records, delete records, or extract data from the database. So again, a lot of work, but that just means that when we get to main activity, we won't need as much code there. So just try to imagine that if you didn't do this, all of this code will be part of main activity, and that's not good coding practice. There's a reason why you can break down your complex code into separate classes, and it's for code readability and easier maintenance. If I had this all in main activity, that would make main activity bloated, will slow it down. Plus, when I try to change something, it might affect everything else. So now if I need to improve DB helper, I don't bother with the other classes there. And vice versa, if I go to main activity, I can concentrate now on the main flow of the program and not worry about the details that are in DB helper. So, so I'll close this for now and go back to main activity and add stuff so that we can use it in the application. Okay, so first things first, we'll add the visual component for this app. We won't really be doing anything fancy. We just want to add stuff that will enable us to see DB Helper in action, because that one doesn't really have an interface component. So I'll just paste in my XML code. Then it will be in the same reference. So I'll paste it in. So take note when you're pasting that this tag up here remains, otherwise it will have compile errors. What you want to do is replace that existing thing with this one. And using the split functionality, you can see immediately what it looks like. Again, it's nothing pretty. There's just a section where I can type in something and then click on a button to add that to the database, and then same thing, I can enter a value here, which is the primary key for the quotations, and have it retrieve that value. So that takes care of our user interface. And nothing fancy, nothing groundbreaking, nothing even that goes to normal Android UI standards. I'll run this. I'll bring up my emulator again, so I should see that. Type. So that's where we'll be entering a code. Right now, this will do nothing, and then here we can type the code ID. Since it's auto number or auto increment, it's just a bunch of integers from 1, with the 1 being the first record, and so on and so forth. Now we'll add the code to main activity to see this actually working. So normally I would start this off by, if we were doing this in an actual coding activity, I'll be doing it line by line, and the imports will be added automatically if it recognizes the objects, but we're not doing that. So when you're pasting the imports, be very careful. These two imports are required, and they get there when main activity is generated. So I'll make a space and then paste in the stuff that I need. So again, they'll become gray because they haven't been used in the code. Now that these items are here, I can add the other items. I'll just delete on create and then add that in. So after adding in, you'll see I actually don't have any errors here, except for the name here. And that's easily changeable. If I do this, it should show me all of the available layouts. So I'll correct that. In your code, you probably won't need to correct this anymore, because that when I pasted, it came from an older source. So I have this now. So a couple of things here, just like what we've done before, we need to define all of the widgets that we will work with. That's just how Android is. We also define a DB helper, because that's how we'll be using the class that we added. So a button, and then the two edit texts. Again, if we look at our screen, two edit text, a button, and then another button. We have an on-click listener so that clicks can be detected, and this is the classic way of doing it. Even if you're not in Android and you're just doing Java user interfaces, you make use of an on-click listening. As a review, of course, in Android, the shortcut is to define a function and then just tag it in the corresponding on-click attribute of the button. So we're just doing a classic implementation here. We're adding on-click listeners to the buttons programmatically. So medyo Java hardcore, or somewhat an old way of doing it in Java, but it does work, and it holds true for non-Android implementation. So we have all of this code here. Notice that we get to call the functionality encapsulated in the DB helper class. Get code to get all the codes, and then what else do we have here? We have a toast message to show the code that we're trying to retrieve. And then we have for add, we call insert code. So now that we have this, let's run this. So we have this here again, and to test it out, I'll put a quote in. Do or do not, there is no try. Plus points if you guys can remember where that quote was used. So I'll add it. Nothing seems to happen. I'll add another one. Give me liberty or give me death. So the field for the primary key is auto increment. So when we do that, it just starts from 1 and then so on and so forth. Every time we add a new record, let's add another one. Yeah. From Austin Powers. So now we have about 3 codes here. If I do 1 for display code, you'll see that there is now a message box there. I'll do that again. I'll bring down the keyboard so you guys can see. It says ID1, code do or do not. There is no try. So that tells me now that when I do add code, it gets added to the database, and then when I do display code, it extracts it from the database. And that is a simple example for how you use SQLite with your Android application. So it's a bit involved. There's a lot of things you have to do, but if you decide that your app needs to make use of local storage, then you do something like this. Again, there's a lot of options for local storage. If the data you need is simple, you probably won't need to go through the lengths of SQLite. But for bigger data, probably yes. And we'll be discussing those in future sessions. Okay? But for now, if you want to make use of SQLite, this is the template you can follow. Hope you picked up something, and good luck with implementing your own version of SQLite in Android applications. And one more final thing, in terms of security, every time An app makes use of SQLite. That database is only for that application's use. So if I have 10 apps and they all have their own SQLite databases, there is no chance for those databases to overwrite each other. A database, when created, is locked to a particular app. And with that, good luck again, and we'll see each other in future sessions.